Hey everyone, Morgan here. So we're going to be looking at doing an answer key for the molarity problems today. All right. So this is number 1. What is the molarity of 4.50 moles of HCl diluted to 1.500 liters? We know that molarity equals moles over volume, which is going to equal 4.500 moles of HCl divided by 1.500 liters. Now that is 3, but paying attention to sig figs, 3.000 molar HCl. Okay? Pretty straightforward problem there, but an important one. Now, question 2, a little more realistic. 20 grams of NaOH are diluted in enough water to make 1.000 liter. What is the molarity? So we start off with our 20.00 grams of NaOH times 1 mole NaOH. Add up the molar mass. You're pretty good at that by now. It's 40.00 for this compound. Nice convenient number. Grams are going to cancel. And this is 0.5000 moles NaOH. Molarity equals moles over volume, which equals 0.500 moles NaOH divided by 1.000 liters, and that equals 0.500 molar NaOH. Okay. I think that's pretty straightforward. Okay. Next one, how many grams of KOH are needed to make 2.00 liters of 1.00 molar solution? This is the most important question, really, of the batch, because this is the type of thing you actually have to do in a laboratory situation. So we know that molarity equals moles over volume. Moles will equal molarity times volume, which equals, we have 1.00, and rather than writing it as molar, I'm going to write it as mole per liter, that's KOH, multiplied by 2.00 liters, liters cancels, and this equals 2.00 moles of KOH. So I take my 2.00 moles of KOH and I multiply by downstairs 1 mole of KOH. Upstairs, the molar mass for KOH is 56.11 grams of KOH. So that cancels that. So now I'm going to grab my calculator here and I'm going to say 2.00 times 56.11, and I get 112.22, but for 3 sig figs that's going to be 112 grams of KOH. Again, this is probably the most important problem of the homework. Okay? That's what you actually do when you're working in a laboratory. Okay, number 4. What volume of NaCl is needed to have 8.75 moles of the solution is 1.50 molar? Okay, molarity equals moles over volume. Volume equals moles divided by molarity, which equals. So I want 8.75 moles NaCl divided by 1.50, and I'm going to write it as moles per liter rather than molar, because then I'm going to see the moles cancel. Grab my calculator, 8.75 divided by 1.50, and I'm going to get 5.83 liters NaCl. Okay, So those 4 problems represent pretty much what one of these, assignments could turn into, any one of those possible scenarios. Now we're down here to looking at some questions about dilution. And C1V1 equals C2V2. Okay? Now, concentrated nitric acid is 15.6 molar. If I want to prepare 1.00 liter of 1.00 molar solution, how many milliliters of concentrate do I need? Okay? So, if C1V1 equals C2V2, V1 equals C2V2 over C1. Doesn't matter whether I choose number 1 or number 2, okay? So 1.00 molar times 1.00 liters divided by 15.6 molar. The molars cancel. Equals. Now I'm going to put this in my calculator. 1 times 1, no big deal, divided by 15.6. Now that's kind of a small number, which was why I said to answer as milliliters. So I'm going to multiply by 1,000 and get 64.1 milliliters. HNO3. Okay. Now, let's do a very, very similar question, but we're going to look at the setup in a slightly different way. This is probably more likely the way your algebra teachers had talked about it. I'll try it as CIVI equals CFVF for initial and final. So my initial concentration is 18, sorry, I didn't quite write that correctly, 18.1 molar. And I don't know the initial volume. But I know it's going to be 2.00 molar times 200.0 milliliters. Now to get V1, I divide both sides by 18.1 molar. That cancels. Okay, so 2 times 2, 2 times 200, sorry. 2 times 200 equals, divided by 18.1 equals, and that's about 22.1 milliliters, molar and molar both canceling. Okay. So I'm looking to make 3.79 liters of 0.5 molar NaOH. How much of the 19.1 molar do I need? C1V1 equals C2V2. So V1 is C2V2 over C1. So I'm trying to make 0.500 molar. I need 3.79 liters divided by 19.1 molar. Molar and molar cancels. So I go back to my calculator. 0.5 times 3.79 equals, divided by 19.1 equals. Now that's a pretty small number in liters, so I'm going to convert it to milliliters by multiplying by 1,000. I'm sorry, I multiplied by 100, so times 10. And that gives me 99.2. 99.2 milliliters. Okay. So that's page 1 of this. I'm going to go back and show you the top half again. All right. Hit pause if you need to. I'll count to 5. All right. Now we're going to go back down here. Look at the bottom half, or bottom third or so, almost. Count to 5. Pause if you need to. And then the very bottom of it, right there. All right, so flipping over to the back here. You have the equipment pictured above. Describe how you would prepare 1 liter of 1.00 molar KNO3 from the solid. Okay, so first off, let's do the math. Molarity is moles over volume. Mole is molarity times volume, which equals, and it's 1.00 mole per liter of KNO3 times 1.00 liters. Liters cancels, that's 1.00 moles of KNO3. Let me add up the molar mass for that. KNO 1, 1, and 3 times 16.00 times 14.01 and times with potassium, I'm going to use 39.10. That's what's on my periodic table. So here, 3 times 16 plus 14.01 plus 39.10, and I'm getting 101.11. So 101 grams times 101.11 grams per mole. So 101 grams KNO3. So here's what I would do. Number one is half fill a 1.00 liter volumetric flask with distilled water. 2, add 101 grams KNO3 massed on a balance. Mix well. Then fill to the 1 liter mark on the flask. With distilled water. What you'll notice is there's always a mark on a volumetric flask telling you the volume. Okay. Now, for my next one, the difference is I'm doing it from a liquid rather than from a solid. So I use C1V1 equals C2V2. V1 is C2V2 over C1, which equals 1.00 molar times 1.00 liter over 12.1 molar. So 1 times 1, of course, divided by 12.1. And I'm going to convert that to milliliters and get 82.6. So 82.6 milliliters. So this time, step 1 will be, of course, half fill a 1.00 liter volumetric with distilled water. Number 2, measure 82.6 milliliters of the HCl with a graduated cylinder. Add to the flask with stirring. Okay. 4, fill to the 1.00 liter mark with distilled water. And 5, mix it up. Mix it again. Okay. So there's your first one. Pause if necessary. There's number 9. Pause is necessary. All right, so for number 10, I am not an artist. Trust me on that. So, molarity is moles over volume, which means moles is molarity times volume. And I have 0.250 moles per liter of NaOH times 1.00 liters. The liters cancels. That's 0.250 moles NaOH times, and the molar mass is 40.00 grams per mole. So this equals 10.0 grams NaOH. Now, we're going to follow these same steps right here, but I'll use the diagrams up there. Find 10.0 grams NaOH. Okay? Half fill that with the water. Then you would add the NaOH in there, mix it up, continue to add water till you get to that line. I'm really not looking for your work to have to be perfect art down there. If you just drew a square as the balance, I'd be happy. Don't worry about it. Okay, so that's molarity number 1. Hope you did well with it, and we will see you again next time. This is Morgan, signing off.